Hi everyone, I welcome you to the presentation of this video, automatic control system. This will be looking at system stability, and we'll be using the formula called Routh array criterion. So this criteria is used to determine the stability of a system from a given characteristic equation. So we'll be given a characteristic equation. From that equation, you're supposed to determine the stability of the system. So when you're given a characteristic equation, like this one, for example, so this is a characteristic equation, and then you want to check if your system is stable or unstable. The procedure is you're going to to draw an array starting with the powers, of course. So this is the S of n. This is a function in the frequency domain. So S of n, which is the maximum power, you'll be dropping all the way until you reach S of 0. S of 0 is basically a constant. So you start with a maximum power, going all the way in that order up to S of 0. Once you do that, you draw a line. And then from there, you start writing coefficients. So coefficients for that one, you'll be skipping one. As you can see, from S of n, you skip that one, and then you do the other one there. So you do the A there, you skip B, you do C, you skip C, you do E. So these are the coefficients. You write this one, you skip this one, you write that one, you skip the next one, and then the other one. So you write those down. And then for the s to the power n minus 1, so if this was s to the power 4, this would be s to the power 3. For the s to the power 3, you write those you are skipping now. So automatically you write the B there, you skip the C, there's the D, you write that one, you skip the E, then there is the F, like that. Once you write those, now you're supposed to fill in these other parameters there, but you'll be using some formulas there. So for you to fill in the coefficient for this one here, you're going to do the following. So if it's for G, for example, this number G, it will basically be you multiply A times D times B times C, and then you divide by B, which is this formula there. A times D minus B times C divided by B. The answer you get, that's what you put there as your G. Okay. You can have another one. Let's say H. For H, you multiply B times E, A times F, divide by B, which is that formula there. You're going to have H. For this one here, which we are calling I, since there are no factors there, it's a 0. So it will be B times 0, A times 0, divided by B, which will be a 0, of course. So I is going to be 0, like that. You come for this one here, you come to this one here. So for this one, it's the same thing. We can say J. If you're putting in J, the number J there, it's the same thing. You multiply G times D, B times H, and then you divide by G, which is that formula there. You're going to have your J there. You can have another one, which is K. K, you multiply G times F, B times I, which is that one there. Then you divide by G. You're going to have this as your formula there. You have that. This one automatically will be a 0 because it will be these times. There's nothing there. This one, there's nothing. Divided by that, it will be a 0. So you're going to have 0 like that. So this system continues all the way until you fill in all this array, which is the Routh array. This is the constant, which will be the constant in the system there. So the A automatically will be a 0 like that. So this continues all the way. I'll just put dots there representing that this can go down all the way until you reach the last one there. So the last one there will automatically be a constant, doing the same things like that. Then you're going to have your constant there like that. So this is the Routh array. So for you to determine if the system is stable or unstable, you check this column. If all the parameters in here are positive, then your system is stable. If there is any number in here which is negative, then this makes your system unstable. So that's how you'll be determining if your system is stable or unstable. Okay, on the next slide, let's look at an example. Okay, so this is an example. It's saying determine the stability of the system represented by the characteristic equation, which is this one here. So we've been given this characteristic equation. We want to check if the system is stable. So for this system to be stable, let's go to our solution. We're using Routh array criterion. So since it has the highest power of 4, s to the power 4, so you write from s to the power 4 up to 0. Even if some parameters are missing there, you put from 4, 3, 2 up to 0 there. But for this one, we are lucky everything is there. So we write s to the power 4, s to the power 3, s to the power 1, up to s to the power 0. Then you put a line like that. So you come with the coefficients. So you'll be skipping coefficients. So you write the coefficient of 1, 18, and 5. Those are the coefficients you put for the s to the power 4. For s to the power 3, you write those you're skipping. So you had skipped the 8, the 16, automatically there's a 0 there. Those are the coefficients we are having there. And then we start filling in this by the formulas I showed you on the previous slide. So for us to have a value here, you multiply 8 times 18, 1 times 16, divide by 8, which is that formula there. You are going to have 16 as the value. That's the one you are having there. For us to have this input there, you multiply 8 times 5, 1 times 0, divide by 8, which is that one there. You're going to have a 5 as your answer there. And for this one here, it's supposed to be 8 times, there's nothing there. 1 times, there's nothing there. So it's a 0 automatically. So you have a 0 there. So you continue the procedure. For us to have this one, it's these parameters now. So it will be 16 times 6, 8 times 5 divided by 16, which is that formula there. We are having 13.5. For this one here, it's the same thing. 16 times 0, 8 times 0 divided by 16, which is automatically a 0 like that. So we are having a 0 like that. For this one here, there is nothing that side. Automatically, it's going to give us a 0. This is the one we are having there. For this one here, it's this times this, that by that, divided by 13.5. We are going to have 5, which is that one there. For these, there will be zeros, of course, because it will be 13 times 0, 16 times 0 divided by 13.5 there. We are having a 0. So that will produce a 0, of course, and the other one will produce a 0 as well. So we are having those as our zeros. So our array is done. Now, how do you determine if the system is stable or not? You check this column. So from that column, if everything in there is positive, then the system is stable. If any of those is negative, the system will be unstable. As you can see, all the parameters there are positive. Therefore, we can conclude to say this system is a stable system. Thanks for watching.